Hi, hello everyone. Welcome back to the TheTecherz. My name is Surmeet, and today I'm going to discuss more about diodes. See, as discussed in the previous videos, diodes acts as walls which allow current only in one direction. This is the basic function, but this can be modified into so many different ways that makes them really valuable in electronics, and that's why I want to discuss more about diodes in depth. See, the smart technology with all the different sensors that exist in today's world was only made possible because of diodes, as their conductivity can be affected by the different energies like light and heat. And using that behavior of the change in conductivity can be used to design our different systems the way they have to work the way we want to. Furthermore, even all the low power, high output products like LED lights are also made possible because they help in plugging of DC instruments on AC outlets. Like you have seen, all the LED lights, they work on DC power, but we can directly connect them to AC power, and diode made them possible, and they consume less power as well. But how was this all made possible? We need to dive deeper and understand its basic function, what is actually going on inside the diode, and then go how these are modified or arranged in a way that can help us develop some amazing products of our own. So let's see. Now let's see how the diode's basic function works, right? As we have already discussed, diodes, they act as an electronic valve, which means that they only allow current going in one direction and blocks in the other direction. And their basic use can be modified to use other ways, which we'll see in next video and even in the second part of this video. They can become great sensors like such as heat and light sensors, and they can be used to attach to connect our DC equipment on AC outlets, because they can convert the AC current into DC current, which another thing we'll see in the next video. Now let's see what happens when we make a diode. What is the equilibrium state, what is its idle state, and how it works in forward bias, reverse bias. First, in equilibrium state. Now when we connect both of these p-type and n-type semiconductors together, a junction is formed. Now during this junction, when this junction is formed, the electrons they get attracted towards the positive charge particles known as holes inside the semiconductor, which is natural that opposite polarity attracts. Now what happens is this electrons, they move in and recombine with the holes to neutralize the charge. They take these spaces. Now what happens after that is all these electrons, they take this space, leaving holes behind in the n-type semiconductor, and the electrons fill the holes in the p-type semiconductor, which further makes the layer at the junction neutrally charged. But the layer this which is called a depletion layer. Now this depletion layer, which is more closer to the p-type semiconductor, now acquires a little bit of a negative charge because of the electrons move towards the p-type, and the depletion layer of on the towards the n-side semiconductor, it forms a little bit of a positive charge in here because of the spaces left behind by the electrons that move towards the p-type semiconductor. Now a depletion layer, this is called a depletion layer, which has its own electric field, which is in the opposite direction of the diode's electric field. Now let's see what happens when we forward bias this diode. That is, how does it start conducting the current in forward bias direction. See, when we connect the positive terminal of the battery to the p-type semiconductor and the negative terminal of the battery to the n-side semiconductor, the electrons from the negative terminal of the battery, pushes the electrons in the n-type semiconductor towards the depletion layer to recombine with the positive charge here. And the electrons inside the depletion layer towards the p-type semiconductor, they get attracted by the positive terminal of the battery. So they move in that direction, which causes the reduction of the depletion layer thickness. And then now the current starts to flow in the diode. But now opposite happens in the reverse bias. When the positive terminal is connected to the n-type semiconductor of the diode and the negative terminal connected to the p-type semiconductor of the diode, the electrons will merge with the holes. They will recombine with the holes in the p-type side, and the electrons from the n-type semiconductor will move towards the positive terminal of the battery, which results in increasing the thickness or width of the depletion layer. So there's and depletion layer is a barrier which stops the current from flowing. Now that's what happens. That's why current doesn't flow in the reverse biased condition. Now let's see what happens when we connect the diodes in series and parallel. If you connect both two diodes in a series, the voltage required to conduct the electricity increases. That means you need more voltage, which would be the sum of the voltage, the threshold voltage would required for one, and this threshold would required with the other. Now, what happens in parallel is the current carrying capacity of both the diode increases. Now let's see what are some of the types of diode that can be made using this basic function of forward bias, reverse bias, and depletion layer. Now what are the different types of diodes that we can make? First on the list is Zener diode. What is a Zener diode? It works in a reverse bias condition. They are designed to reliably work in that way. Why? Because they have a low reverse breakdown voltage, which means it requires lesser voltage as compared to normal diodes to start conducting current in a reverse bias condition. Good. And then breakdown, but the breakdown in this one is controlled. Otherwise, in normal diode, the breakdown happens when the breakdown happens, the diode, we cannot use the diode anymore. And they can also be used as voltage stabilizers or surge protector, which means that if there's any surge of current or anything in the circuit, they can stabilize and protect the entire circuit. And next up is Avalanche diode. They are very similar to Zener diodes, and they are designed to experience breakdown at a specific reverse bias voltage. Unlike a Zener diode, they're optimized for their function than Zener to exhibit small significant voltage drop, because when Zener diode is working, it maintains a voltage which is higher than the breakdown, but the Avalanche diode, they have a significant voltage drop, but it's very small as compared to the Zener diodes, and they are used for voltage referencing, protection, RF noise generator, or radio frequency noise generator, random number generator, microwave frequency generator, and single photon detectors. What next up is LEDs, which is light emitting diodes. See how the LED works is that when electrons and the holes recombine, they release a particle called photons, which are light particles. And when this happens, this process is actually called electroluminescence, right? And the color of the LED is depend on the energy required to cross the band gap between the electrons and holes, which in turn is dependent on the material of semiconductors used. So it's basically the LED are made from a different material than our normal diodes or any other diodes, and that's why and whichever materials we use there, that's what and the material decides the color of the LED. Now next up is photodiode. Photodiode is actually, the function of photodiode is reverse of LED. It converts the light into electricity, unlike the LED. And what happens is when the photons or the light particles that strike on the surface, they create an electron and hole pair, and they go to their respective electrodes, and that's how the current flows. This basic function is the function of our solar panel cells. That's exactly what happens on solar panel. When the sun rays hit on the panel, they they create the electron hole pair, and which goes to their respective electrodes, and that's how the current forms. That's what the DC current is. Now next up is Varicap. Varicap is variable capacitor, or it's also called a varactor. They always work in a reverse bias condition. What happens is, if you take a normal diode and start making it work in a reverse bias condition, the depletion layer that we mentioned before, that acts as the dielectric of the capacitor, which stores the charge. Now, when we increase the reverse bias voltage, the capacitance decreases. So, uh, and lower the voltage, higher the capacitance. So that's why it's like the capacitance is actually variable in this one. That's why it's called a variable capacitor or a varicap or a varactor, unlike your normal capacitors which have a fixed capacitance. So with this function, it can be used in a frequency multiplier, amplifier circuits, or even voltage controlled oscillators. Next up is a tunnel diode. See, in tunnel diode, these are heavily doped semiconductors. They're very highly doped, thus resulting in the depletion layer to be very narrow. Now what happens is, the electron that flow through are flowing because of the quantum mechanical effect, which is also called as a tunneling, which is that they just tunnel through the depletion layer for flowing of the current. And this one has a negative resistance. That means after voltage increases, they have a negative resistance, which means the higher the voltage, the lesser the current will flow. Now, after a certain voltage point, if the voltage is increased to a certain point, now they start behaving as a normal diode, right? And in reverse bias, it is also called as back diodes because electrons tunnel through. They can act as a fast rectifiers with zero offset and extreme linearity. We will understand this more when we are covering up the rectifiers. Rectifiers are the circuits called rectifier is what we call a circuit made with diodes to convert AC into DC. So when we are learning about rectifiers, that's when we understand more about this function. And due to this effect, they can be used as oscillators, amplifiers, switching circuits, frequency converters, detectors, and can function even at microwave frequencies because they work on a very low voltages. Now next up is Schottky diode. In Schottky diode, the junction is semiconductor and metal instead of like two semiconductor p time and n time. This one has only one type of semiconductor and then it's a metal. Typically it's a n type and then a metal. Now because of this, they have lower forward voltage resulting in higher switching speeds and better efficiency. uh, so they even require low reverse recovery time, and they can be used in voltage clamping. We will learn about clamping circuits. They can prevent discharging in PV systems when if the PV system is an off-grid connected with battery, they can prevent batteries from discharging into your normal grid, which which we want to prevent our batteries to do. Um, and they can protect the parallel strings inside a PV system as well, and they can be used as rectifiers because of the high switching speeds and everything. Now here's a question for everyone, and anyone who gives the right answer to this one, they will be featured or they will be mentioned in my next video or even on my Insta page. I'll be posting this question everywhere. Whoever gives me the right answer, I will mention their name in my next video. So here's the question for everyone: does a diode acts as an ideal open circuit, which means if in a reverse bias, they will stop conducting current no matter how much voltage you provide on it, or an ideal conductor in forward bias, which means
whatever the current or whatever the voltage is from the source, it will pass on all of the voltage and all of the current. And why? Support your answer. Alright, so that's it. That's for today. Next time we will be discussing about, as I said, more about the rectifier, clipper, clamper, and that would be all for the diodes. Thank you.